Hello everyone, this is Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar in Delhi College of Commerce, University of Punjab. So today is the 13 day training session. It is the 13th day, and we are going to discuss the panel framework that we have previously covered. We have previously covered T less than 25 and N less than 25 procedure, in which we have analyzed a data set that have a time dimension less than 25 and a cross-sectional dependence which was also 25. In that case, we have analyzed a data set having a high income group data set. For example, if you can see here the T and N less than 25. This was the data set that we have discussed in our last session. If you can see here, there are a number of countries which are less than 25. These are basically 19 countries. And if you see the number of time period, it starts from 2000 and go to 2021, it is almost 22 years. So our criteria was T less than 25 and N less than 25 was met here. So we have analyzed this data set with fixed effect, random effect, and pooled OLS, and we have found a fixed effect regression model here according to Fossman specification test. And we have also analyzed three assumptions like cross-sectional dependency, like group-wise heteroscedasticity, and like the third one was first, second, and the third one was serial correlation. These were the three assumptions that we have analyzed with the data, and we found that fixed effect regression model was finalized. Now, today we are going to cover next assumption, and the last one. The middle two assumptions will be met in some other day. So we are going to cover if we have T greater than 25 and N greater than 25. It means you have a time dimension which is greater than 25 and you have a cross-sectional dimension which is also greater than 25. So in that case, I am going to analyze a data set which is T and N greater than 25. This is a data set which is basically related with middle income countries. So I have symbolized this data set T and N greater than 25. So I would like to share this data set with my participants here, like Mr. Vakar, in order to have a brief analysis on these data sets. So let's have T and N greater than 25. So I have shared this data set with Mohammed Bakar and also with Adnan Afzal, the second participant. So this is the data set that we are going to use for today. So let's open this data set. I hope you have downloaded the data set that I have shared with you. First, you need to see this data set. If you see the IDs, ID is basically the number of countries here. So if you see the ID from the first one to the last one, there are total 53 countries here. So our first condition was N greater than 25. N is basically the number of countries here, number of countries. And if we see here, the number of countries are 53, which means N is greater than 25. The second condition is T. T means number of years here. Your time dimensions is basically the T. So first we need to see the T here. If we notice from the year, the numbers start 1980. The number of The year start from 1980, and it's basically lasted for the first country on 2020. And if we notice the observation here, it becomes 41 observation. So the time period here is 41 actually, 41. So T is also greater than 25 years. So when n is greater than 25 and t is greater than 25, it means we are going to meet this condition, the most left one condition. So what we need to do in this condition, first we need to, if we are going to use a new panel data, first we need to declare our data set to be panel. Then we need to consider the usual methods like fixed effect, random effect, and pooled OLS. And then we need to check the cross-sectional dependence. That is one of the assumption of panel data set that we have analyzed in our previous discussion. This is the cross-sectional dependence. And if you remember, uh, the method that we have finalized previously using Haussmann specification test, if fixed effect is final, we need to check the cross-sectional dependence on fixed effect. If random effect is final, then we need to check the cross-sectional dependence on random effect. And if pooled effect is final, then we need to check the cross-sectional dependence on the pooled effect. So always remember that you need to follow the usual pattern that you have used previously. Like you need to declare your panel data and you need to analyze the other thing in the usual way. So what we need to do after the cross-sectional dependence, if you found the cross-sectional dependence, it means if PR value is less than 5%, then you need to check the second generation panel unit root, which is CIPS test. You need to apply this. But if you do not found cross-sectional dependence, it means if your PR value is greater than 5%, then you need to consider first generation panel unit root test like IPS and LIN11 test. These are the tests that you need to apply on panel unit root if no cross-sectional dependence is found. But if cross-sectional dependence is found, then you need to apply second generation panel unit root test. So what will happen if no cross-sectional dependence is found? You need to apply the panel unit root test. If you found your data to be stationary at level for both DV and IV, then you need to consider pooled OLS, random effect, fixed effect, or seemingly unrelated regression or so. But if you found your DV to be, you can say, stationary at first level and your IVs stationary on the mixed level, then you need to apply ARDL method, which is panel ARDL method that you are going to apply here uh, for considering your hypothesis testing. But if cross-sectional dependence is found and you need to check the stationarity using CIPS test as a second generation panel unit root test, and you found your DV is stationary at level and IV is also stationary at level, then you need to apply the common correlation effect. And if your DV is stationary at first level and IVs are stationary at mixed level, then you need to apply dynamic common correlation effect. So these are basically the basic consideration that you need to consider here. But first, what is panel unit root testing and how it can affect your analysis, your procedure? So first you need to understand the panel unit root testing here because in that case, if cross-sectional dependence is found or it is not found, in both cases, you need to run the panel unit root testing. Either you are going to run the panel unit root using the CIPS, or you are going to run the panel unit root testing using first generation panel unit root test. So you need to understand the basics of panel unit root testing first. Always remember your variable, dependent and independent variable, must be stationary at same level. Either they should be stationary at 0 or 1 or 2. And sometimes they may be stationary at mixed level. So then you proceed with the step fixed effect, random effect, pooled OLS, or panel ARDL that I have discussed with you. So how to consider the panel unit root testing? You may have a lot of tests here, which are known as panel unit root test. But first, you need to understand the difference between different panel unit root testing, like first generation and second generation panel unit root test. This is a document I will share with both of you. These will let you know the basic econometrics behind panel unit root testing. I would like to share with both of you, like with Adnan Afzal and with Muhammad Wakar, because before applying this procedure, you need to understand the basics of panel unit root testing so that you may be able to apply it more sophisticatedly in this procedure. So, unit root and panels. First, you need to have a general idea what is panel unit root testing. Unit root test for time series are known to have low power. So if you are using a time series dataset, it means in that case, if you are using unit root test, it may have a low power. It appears attractive to check whether a variable has a unit root. It becomes stationary after taking the first difference only using parallel data for several individuals. So this is the idea behind panel unit root testing. So this, of course, only makes sense in the presence of some homogeneity across individuals. An extension is the multivariate generalization co-integration in the panel. So we need to understand the basic idea behind the panel unit root testing. The first thing that you need to understand is panel asymptotics. What does it mean? Particularly, unit root panel always uses several concepts of letting sample grow beyond all bounds. You need to understand sequential limits investigates whether if t is goes to infinity for fixed n, and then n goes to infinity for fixed t, and joint limit t and n go to infinity and simultaneously. But in our case, there is no infinity in our case. Our n and t are limited. So, what we need to understand regarding the first generation and second generation panel unit root testing. The first generation of panel unit root test assumed that the individuals are independent. So this is the basic idea behind the first generation. It means there should be no cross-sectional dependency in your panel in case of first generation. So there should be no cross-sectional dependency in your panels. This is the basic thing that you really need to follow for a first generation panel unit root testing. So if you want to apply the first generation panel unit root testing, then you need to understand that there should be no cross-sectional dependency in your panel. Like I have discussed here, uh, if you found no cross-sectional dependency, then you can apply the first generation panel unit root test. But if you find cross-sectional dependency in your panel, then you need to apply the second generation panel unit root testing. So this is the basic difference between first generation and second generation. So here is the same thing they are discussing, that your individuals should be independent. It means they are not cross-sectionally dependent on each other. There should be no cross-sectional dependency. Uh, in that case, you need to use LLC and IPS test as a first generation test in case of panel unit 2. So these tests are advised, if you can see here, they are already mentioned here, IPS and LLC. So the same tests are mentioned here, IPS and LLC. So these are the first generation panel unit root test. When we are going to use the Stata software for applying the test, there are a number of tests, unit root test, panel unit root test are available. And we need to decide whether we need to use LLC, IPS or CIPS, which is basically the second generation panel unit root test. So first we need to understand this difference. In case of second generation, if you are going to use the second generation panel unit root test, always remember that it consider dependence among individual. So in that case, we can say there should be cross-sectional dependence in case of second generation panel. There should be cross-sectional dependence. So this test assume that cross-sectional dependence may be found in your panel. So in that case, if cross-sectional dependence is found in your panel, you are going to use second generation unit root testing, which is CIPS. Now we need to see what does it mean and how this option is available in Stata. So we need to explore both options here. So this is the basic idea. When you found cross-sectional dependence, you are going to use the second generation panel unit root test. And if you do not found cross-sectional dependence, you are going to use first generation panel unit root, which is LLC and IPS. So what are the other things that you need to understand here? LLC is basically the first generation panel unit root test. LLC and IPS. They are both first generation panel unit root test. First, you need to understand what is LLC. LLC is Levin-Lin-Chu test. Levin-Lin-Chu, that is the full form of LLC test. Levin-Lin-Chu are basically designed by their author in 2002, Levin, Lin, and Chu. They are basically the author who have developed this stationary test, and this is the LLC test built on Dickey-Fuller test. Dickey-Fuller is the basic panel unit root test for a simple time series data. If you are using a time series data, then you need to apply the Dickey-Fuller test as a unit root testing. So it is built on the same assumptions which Dickey-Fuller is basically using. So LLC is assume the same things that Dickey-Fuller test for unit root testing uses. So with the deterministic part, known constant and so on, there are some assumptions here. Then there are three steps that you need to consider for applying the LLC. Uh, there are these are the econometric steps that we do not need to consider for Stata, because Stata automatically analyze these steps using its analysis procedure. But if we need to apply the LLC manually, then we need to follow these steps econometrically. So this is the first step. They would consider, this is the second step they would consider for LLC. This is the third step they would consider for LLC. Then the second one test is IPS, which is IM Pasran test. I need to highlight it. This is also the this is also the first generation unit root test. It is the short form of this test is IPS test or IM Pasran and Shin test. If I would like to write here, IPS test, IM Pasran and Shin test. As I have already mentioned you that this test is required in case if no cross-sectional dependence is found in your panel data statistic. So to sum, a drawback of LLC test is that it imposes a common IM Pasran. So you can apply this test as an alternative of your LLC test. Then there is another test which is known as the Bretung test. Uh, this is basically another test which you can use in case of first generation. Then this is the basic econometric behind this test. Next is the Fisher type test. They are basically used another one. Then which first generation panel you test to use? There are some assumptions that you need to understand. It means Fisher type test, uh, then the Brayton test, then IPS test, and the LLC test. There are four tests that you can use for first generation unit root testing using panel. So there are four options available for you. Levin-Lin-Chu. The second one is the IPS. The third one is Breton test. And the fourth one is Fisher type test. Let me show you from our Stata so that we may be able to find out these tests in Stata. If we see the statistic command here and we like to open the panel data, here the unit root test option available. If you open here Levin-Lin-Chu, Batterung, IPS, and Fisher type. So they are available. Fisher type, IPS, Batterung, and Levin-Lin-Chu. These are available. And these are considered as a first generation unit root test. So we can assume that these tests are available. So which test to use in the first generation? They have provided some basic analysis things that you need to understand. Like Holoskova and Wagoner 2006 compare many tests in extensive Monte Carlo simulations. So none of the tests dominates its rivals for R design. Battering test has the advantage that it needs to no tabulated correction terms. A panel version of KPSS stationary test by Hadri performs poorly and should not be used. So they have recommended that Hadri test should not be used because it performs poorly. If we see here, we have a test, Hadri LM test. So they have recommended that this test should not be used here. All right. Uh, Among the Fisher type tests, the version by Choi has the best performance. So they have recommended you can use the Fisher type test. You can use the Battering test. You can use the IPS test. They have basically restricted that you should not use Hadri test here. So the next thing is cross-sectional dependence. That is the first consideration that you need to check here. So first generation panel unit root test can perform poorly with cross-sectional dependence. It means if cross-sectional dependence is found in your panel unit root, then you should not use the first generation panel unit root testing if cross-sectional dependence is found. So it means you need to consider the other unit root testing like CIPS. So we need to understand this scenario here, that how cross-sectional dependence can change our analysis procedure. So when the CD test, when the cross-sectional dependence is found, we may want to apply the second generation test. So it is basically recommended here that whenever you found cross-sectional dependence, you need to apply the second generation uh, test. So here is the Pasran CADAF test. Among the second generation unit root test, Pasran CADAF test, or it is also called the cross-sectional augmented Dickey-Fuller test, is the simplest. So we need to see whether it is available here. Pasran test. There is IM Pasran test here. So it means we need to consider, we need to download Pasran CADAF test in the Stata version in order to find out whether it is available or not. So we can find out Pasran CADAF test. Let's pause here. Pasran CADAF test. It is available in case of unit root testing, and it is a simple panel CADF test for unit root. We need to check it, and we need to see how it is available so that we may be able to find out its basic CADF panel. We can also check it here if it is, we need to install it. First, we need to check it using help CADF. It has provided 3 packages. We need to check which one is for unit root. So they have checked PESCDF module to perform Pasran CADF panel unit root test in presence of cross-sectional dependence. So when we have cross-sectional dependence, we can use this test. So they have provided here. We need to install it because it is not already available in our commands. So they have provided it here. We need to check the basics of this test also. Like we can type here help and PESCADF. We need to check what is the specific condition here. How can we apply? So if we need to apply this test, they have mentioned here, if your number of countries is greater than 116 or country less than 140, you need to use 2 lakhs. If your number of countries is greater than 116 or less than 140, you can use 2 lakhs with trend. So there are a lot of procedure they have provided here. So we need to check which procedure is basically being used here. The next thing that we need to consider here that we are using here, this is the first option that we can use with cross-sectional data. After 1 minute, the meeting is going to end. Please join using the same link so that we can proceed further in order to have more detail on second generation panel unit 2 testing. So please join again using the same link so that we can be